This is AP Precalculus. This is the review for the AP test. We are on the 3-peat worksheets to review for that. This is worksheet H. Again, you should be averaging about 1 minute and 57 seconds per question, just because we're supposed to be doing non-calculator questions. We have 28 questions in 55 minutes, which comes out to 1 minute 57 seconds per question. All right, so in this first one, this one, if I saw this one, I would probably wait to come do it in the past or after I solve everything, because I know this one just takes a lot of time. But let's go ahead and dive in. So how do we do this one? The first thing I'm noticing is I probably want to factor the numerator and denominator. So the top is going to factor as x minus 3 and x plus 1. What two numbers multiplied to negative 3? Well, 3 and 1 are the only numbers, and you have to make sure you get the negatives in the right spot. It's the middle number is negative, therefore the negative goes with the larger number, negative 3. The denominator is a difference of squares. I happen to know that 1 is a square and x is literally squared. A difference of squares always factors as a conjugate pair, meaning they're the same numbers, 1 and x, 1 and x. Where do those numbers come from? The square root of 1 is 1, the square root of x squared is x, and then one of them is a plus sign, one of them is a minus sign. All right, I'm also noticing that there is the same term up here, same linear factor that will eventually be crossed off, and that will become what is known as a whole. And wholes don't really change signs as far as I've ever seen. So whenever I have a minus 1, that will never change signs, but I should still include it because I'm noticing this one is not equal to. So technically a whole you can't be equal to. So I do need to include on my sign chart for this problem. So let's solve this and say, okay, set the numerator equal to 0, set the denominator equal to 0, so we can look for where we change signs. And I can say x minus 3 times x plus 1 is set equal to 0, setting the top equal to 0, and setting 1 plus x times 1 minus x, setting the bottom equal to 0. Using the zero product property, you're setting each 4 of these things. I meant to do that with a laser pointer. Each 4 of these things is set equal to 0, so you can say that x minus 3 could be equal to 0. You can say that x plus 1 is equal to 0. This is x plus 1 again, so I'm not going to solve that one twice. And 1 minus x is set equal to 0, and therefore x is going to be 3, x will be negative 1, and x will be positive 1. So let's make our sign chart. Ta-da! All right, sign chart is going to have a 0 at negative 1, a 0 at 1, and a 0 at positive 3. I happen to know that this this value right here, which is x plus 1, which is that x plus 1, which is that x plus 1, when we have a 0 at negative 1, or not a 0, but a whole, I guess, at negative 1, this one will not change signs. So I can come down here and say, this one is not going to change signs. I'll write a note to myself. It's a whole. So if this value is like a positive, then it switches over here. It'll stay a positive. It will not change signs when I jump over the whole, as a little shortcut. And I happen to know that this x minus 3 and this 1 minus x are to the power of 1 and power of 1. When I'm two odd powers, that means when I jump over that 0 or jump over that vertical asymptote, it will change signs because I have odd powers. Even powers will not change signs when you jump over those points on my sign chart. So I can fill in this sign chart relatively quickly. I just need one sign and I can go from there. I'm going to choose the rightmost side because I have that rule that says, hey, if I have a positive x squared, and a negative x squared, that means I should be having a negative out in front. So it should be a negative out in front. So again, that was done really quickly. I want to make sure that I'm slowing down. What I'm seeing here is this is not written in standard form. What I should have written here, I should have had this turned into negative x squared plus 1. These are the same thing. I just rewrote it so it's in standard form, aka the highest degree is out in front. If I'm looking at the highest degree terms, so I'm kind of ignoring all of you, I'm seeing that I have a negative on the bottom, a positive on the top. A positive divided by a negative is a negative. Therefore, I have a negative on the very far right side. It's a cool little shortcut of looking at those leading coefficients to figure out what that sign is over here. And whenever we jump over something that has an odd degree, this was an odd degree for our x minus 3, it is going to change to a plus sign. And again, just going to jump over this 1 right here, which came from here, which was an odd power. Odd power, again, is going to switch signs. It's going to switch to a negative. And a whole will not change the sign. So when I jump over the whole, it should still stay a negative. If you don't believe me, you can do test values. Test values is a slower way of doing things. You say, okay, well, if I plug in a 0 here, if I plug in a 0 to this factored form, which is the fastest way of doing it, well, maybe not. Like you can say it's still plugging in 0 is kind of nice to plug it in here. Usually we plug it in the factored form because it's pretty straightforward. You can say it's a negative times a positive, which is a negative. It's going to be a positive times a negative, which is, wait, is that right? If I plug in a 0, this is going to be a positive times a positive, because 1 times 1 is a positive, and that one is a negative and a positive. Check it out. Bottom is positive, top is negative, and then negative divided by positive is indeed a negative. You could test in a bunch of different points, but you'll get the same answer. I'm just showing the more shortcutty method. You'll realize I've spent a lot of time on this problem, which is why I wanted to skip it at the very beginning. Where is this thing less than 0 and not equal to 0? Okay, so it's less than 0 here. It's less than 0 here, but it's equal to 0 here. So I have to skip over that point, which is kind of frustrating. So everything from negative infinity all the way to negative 1, negative infinity to negative 1, negative infinity to negative 1. Okay, so A and B are limited. And then I need now to say from negative 1 to 1, from negative 1 to 1, from negative 1 to 1, good. And then finally from 3 to infinity. This one is missing 3 to infinity, so therefore that's out. And the correct answer is D. Whew, a lot of work. Let's try number 2. Whew, okay, a much easier question. On this one, you basically just need to sketch a graph of this and you're good to go. So there's 2 parts to sketching a graph of an exponential. I know it's exponential because this is a variable in the exponent. And the first thing that I'm looking at is the coefficient. This coefficient out front is positive. If it's positive and you're looking at the graph, that means you are not graphing the function in the bottom half. Scribble it out. It's going to live only in the top half. Alternatively, if you had a negative, that would mean that the top is not where you're going to be graphing it, and you are going to be graphing it in the bottom. So we're graphing in the top on this one. And then the next thing I need to look at is the base underneath the exponent. This base is small. It's smaller than 1. If this base was bigger than 1, things would change. If I have a small number, this is exponential decay, and I have a graph that looks like this. If this number was bigger, then it would have been a graph that looks like that. But that's not the case, so let's erase you. All right, so here's our graph, and what do we know? I notice that this graph is going down, 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 or you can say that the slopes are negative, therefore it is decreasing. So H is always decreasing. It's between C and D, just based off of decreasing. And I happen to know that this is always concave up. It's always trying to make a smiley face here. Concave up is smiley face. Correct answer here is C. In number 3, we've got a sinusoidal function. Oh, okay, so it says max is 14, the minimum is 4. And these x-coordinates are actually not useful. Maybe they're useful for a second problem where you have to figure out period. We don't have to figure out period because A is our amplitude and D is our midline. So we can kind of ignore those x-coordinates, which is very atypical in an actual AP test. The actual AP test will not give you red herrings like this where they say, haha, you didn't actually need that data. Everything that you're given in the problem should be used. At least that's the way AP Calculus is. I assume AP Precalculus is the same way. So what's going on with the amplitude? Well, I had a height of 14. I went down to a height of 4. So as a quick little sketch here, here's a height of 4. Here's a height of 14. I have some sort of sine function that's going like that, right? I'm coming all the way down here to the height of 4, which means where is the midline, right? The midline is halfway in between, and I can say I went down a total distance of 10, which is where these 10s are coming from. But the problem is that's not how you calculate the value of A. A is the distance from the midline to this maximum, or the midline to the minimum. So you can just divide that distance by 2. 10 divided by 2 is 5. So we know it's between, I meant to, right here, it's in there. There we go. It's between A and B because these have the correct value of A. And the next thing we need to figure out is what is the value of this midline, because D does affect the midline. Well, the midline is just the average of the maximum and minimum values. So I can add these together and divide by 2. So 14 plus 4 divided by 2 is 18 divided by 2, which is 9. The correct answer is A. All right, that concludes our 3-peat H worksheet. Thank you for watching.